Hello students, greetings of the day. This is your NE Rao, faculty in physics from VIP classes. Now today we'll talk about apparent weight of an object, okay, in a lift. Apparent weight of an object, okay. Apparent weight of an object in a lift, okay. So actually what does actually weighing machine measures, okay? First of all we should know, then we'll talk about apparent weight of an object in lift. So for example, so we are having a weighing machine here, okay. When a man stands on it, what happens here? So first of all, the forces acting on it, his weight acts vertically downwards, and as he's pressing this particular balance, right? So the pressing force is here like this. As a reaction, normal reaction will be like this. So if you consider the free body diagram of the man, the forces acting on the man are, what are the forces acting on the man here now? The forces acting on the man will be actually his weight acting vertically downwards. So he is pressing the weighing machine downward. So weighing machine also exactly exerts equal and opposite force in upward direction, isn't it? And he is in equilibrium on the lift. So what you can say, normal force will balance weight, right? So here whatever the force he exerts on the machine, same is the force being exerted, and that force we are called pressing force, called normal reaction. So from this we understand that weighing machine measures weighing machine measures the force acting on it, and that of course is balancing here weight. Now so if the same person, if he is moving in a lift, for example elevator, so where he is standing on a you can call a weighing machine here. Now the lift is accelerating vertically upwards. So now if we consider forces acting on the man, what is FBD? The diagrammatic representation of all the forces acting on the object is called its FBD. Now if I consider the man of mass m standing on weighing machine here, okay, his weight will be acting downward mg, and as he is pressing this particular machine with some force, so machine also presses the man in the vertical upward direction with n value, and as a result entirely thing what happens, entire system is accelerating upward. Now if you write the net force equation from second law, we know all of you, F net is mass into acceleration, yes or no? So here upward force is normal reaction, downward is weight, so net force will be, and body moving upward direction, so normal reaction upward, weight downward, so net force upward direction is n minus mg. This must be equal to m into a, so n will be how much beta? mg plus ma, which is equal to m into g plus a. You're getting? So actually how much here force? So this is the normal reaction acting on the man, and that is the force which the man exerts on the weighing machine. Therefore the weighing machine reads how much reading now? N is equal to mg plus ma. You can say n is equal to mg plus ma. When he was standing normally at rest, when the elevator was not moving, that normal reaction was mg, actual weight. So now when he is moving in an accelerating lift in the upward direction, what is happening here? Normal reaction is here increasing. N is equal to mg plus ma we call, isn't it? So here we are talking about with respect to ground frame. If you imagine what the forces acting on the man, we are talking here, mg downward, normal reaction upward, he is accelerating upward, so n minus mg is equal to ma. Same thing we can also do in non-inertial frame by taking pseudo force into account, isn't it? So that also we can talk about here. What is pseudo force? Pseudo force is fictitious force, okay, which we take in accelerating frame of reference in order to apply Newton's laws. So now if I consider a man is standing over here, and if I consider lift frame, even though lift is accelerating upward with respect to ground frame, but as the man is inside the lift, so with respect to lift he is at rest. Now is in equilibrium. So if you want to talk its equilibrium, that is weight will act vertically downward, isn't it? And a normal reaction whatever he exerts, the weighing machine also exerts same thing, floor, normal reaction upward. With respect to lift frame he is at rest. So whenever we are talking with respect to this kind of accelerating frame, we know that we have to consider pseudo force opposite to acceleration of the frame. Frame is accelerating upward, so pseudo force will be downward, that is m into a. He is in equilibrium with respect to lift frame, so upward force should balance downward force, that is mg plus ma. So what will be n value will be here? M into G plus A. Therefore, the lift is accelerating upward. You can say what? The normal reaction experienced with a person, okay, are the same force which acting on the what? Weighing machine, which it measures is mg plus ma, which we have taken here. Okay, so when man is stationary, so he exerts the force, okay, a normal reaction is experiencing, that normal reaction balancing his weight. When the lift is accelerating, so we are talking with this a ground frame, so net force is equal to mass into acceleration. So you can say n value is mg plus ma, so it is showing more than the actual weight. Okay, or we can also do by any accelerating frame, we talk about a what? Fictitious force, pseudo force for applying Newton's laws. Therefore, when accelerating frame is upward, pseudo force is downward. So you can write down and you can talk about equilibrium. Okay. Now this is the case when elevator or lift is moving upward. So the lift moves downward or accelerates downward. Okay. So with some velocity, with acceleration a. So man is standing on the what? Platform or weighing machine inside the lift. So if he's going downward, if I draw the ABD of the man, so what happens here? His weight is what? Mg is acting downward, and as he is pressing the machine, okay, so machine also presses him with the same force, that is n, and entire system accelerating here downward. So you can write down the equation now. Net force is moving as the acceleration, net acceleration downward. So you can write down mg minus what? N upward is equal to m into a. Downward force minus upward force. So from this you can understand n value is mg minus ma. If we take m common, this is g minus a. So normal reaction, what happened now? M into g minus a. So this is g effective is here, g minus a we call. Here in first case, g effective is g plus a we call. Okay. So here weight appears to what? Decrease here. Now here also we can talk also if the lift accelerates downward, okay, or if it falls freely. That freely means what? With the acceleration a is equal to g, students. Okay. Now if you consider the ability of the man, same case we can talk, but in this formula you can write substitute here g is equal to a. So normal reaction how much now? Simply m into g minus g. So normal reaction force is 0. He won't experience any force. So he won't experience any force means he is not exerting any force on the weighing machine also. Why? When you talk about his ability, so his weight mg acting downward. So if he presses down the floor with n force, floor also exerts a what? Same force. So now here and entire system is going down with g. Write the equation mg minus n is equal to what? Mg. So n is equal to mg minus mg, which become equal to 0. That means so he is not experiencing any force and he is also not exerting any force on the floor or machine. Therefore machine reads how much? 0, and this condition we call as what? Weightlessness condition. So even though like same case like on a big hillock, you are jumping with some what? Load on your head. When you are moving here downward, no, if you draw the ABD of this particular man person, okay, so his weight is acting here downward mg. This weight exert force on his head, and head also exert force on the weight upward. So the whatever the force, so for this equilibrium of this box kind of thing, if you consider on this normal force upward, and the weight of the box is downward, and for the ABD of the man, what is the force he exerts on the box? Box also exert the same force n, isn't it? So he is exerting force on the box, box exerting force on him, the same force, right? And moreover, so when you talk about when he is falling here freely, okay, say when he is falling here freely, if you consider what you can say, ABD of the man, if you talk of here, is falling free, no normal legs from the ground, isn't it? So what is the force the box exerts on him? He also exerts same force on the box. Now if I draw the ABD of the box here, box weight mg will be downward, as head of the man exerting force n, okay, on the box, okay, so that will be upward, and the box as a result what is falling? It is also falling g, and man is also falling with the same force what? Here mg, his own weight. So if you write equation here, this mg minus n is equal to what? Mg, n is equal to mg minus mg, which also 0. That means whatever the force he exerting on the box, box also exert the same force on him. So the on the box he exerting force n, so box also exerts same force n. How much exerting? 0. That means even though he is holding on his head and when he falls freely, no, he is not exerting any force on the box also not exerting any force on him. Why? Both of they are falling with the same g. So no normal reaction, no contact here. Okay, both of they are falling freely. So he won't experience any kind of force or weight because of the box. Why? Both of they are falling with the same G. So like this we talk about effective value of the G and accelerating lift, you can say. Okay, so normal reaction. So only keep in mind, so what does weighing machine measures? Weighing machine measures the force acting on it. Okay, and in turn that is becoming equal to what? Weight of the person. That's how we are measuring the weight of a person in a lift. Accelerating upward means m into g plus a, downward means m into g minus a, free fall means no weight experiencing, that is called weightlessness condition. Fine. So thank you all, please do subscribe. Okay, and stay tuned, and thank you all. So have a good day. Bye.